So today we are going to be looking at the introduction to machine learning. Now, in our daily lives, we actually make use of machine learning models without actually knowing, right? We make use of machine learning models in our daily life without actually knowing. Now, for most of us that actually make use of iPhones, okay, when you actually want to unlock your phone, there is what we call a face ID, right? When you want to unlock your phone, maybe when, let's say for example you got a new iPhone and you have to set up your face ID, that you put your face into your phone, okay, that is what we see it as. Then when you want to, whenever you want to unlock your phone, you just have to use your face and your phone gets unlocked, okay. Now, also for those of us that also use iPhone, there's a model that is on our iPhone that is called Siri, where we can actually communicate with this model to actually do some things for us. We can actually ask this model to set up a meeting. We can ask this model to call someone or send a message to someone. Okay. So in our daily life, we actually make use of machine learning models without actually knowing. Now, our Face ID, Siri, right, and other various applications we make use of in our daily lives. These are examples of machine learning models. Okay, so in our daily life, we actually make use of machine learning models without actually knowing. Now, the big question is, what is machine learning? Now, when we are talking about machine learning, right, one thing you need to understand is that machine learning is a branch of artificial intelligence. Now, please look over here. Let's say we have this diagram, this oval shape here, okay? And let me divide this, okay, into three. Let me divide this into three. So let's say in this oval shape here now, we have artificial intelligence. Then here we have machine learning, and here we have deep learning. Okay, now I'm trying to explain something using this diagram. Now, one thing you need to understand about machine learning is a subset of artificial intelligence, right? Machine learning is a subset of artificial intelligence. While deep learning is a specialized area within machine learning that makes use of neural networks. Okay, that is one thing you need to understand. Machine learning is a subset of artificial intelligence, and deep learning is an area within machine learning that actually makes use of neural networks. Okay. Now, today we are going to be concentrating on machine learning. Now, the big question is, what is machine learning? Like I mentioned, machine learning is a subset of artificial intelligence. Now, machine learning focuses on building algorithms. Okay? Machine learning is a subset of artificial intelligence that focuses on building algorithms, okay, that helps a computer to learn from data and make predictions using data. Now, there's one word you should actually pay attention to here, and that word is data. Now, one thing you need to understand is that algorithms, machine learning algorithms are actually built on and from data. Okay, because it is actually the data that is being fed to the machine learning model. Now, when this data is being fed to the machine learning model, the machine learning model tries to understand this data. It tries to see seasonalities and patterns in this data. Okay, it tries to learn from this data, see seasonalities and patterns from this data, and for after learning from this data, it uses whatever it has learned from this data to make machine learning, to make predictions. Okay, to make predictions. I'm sorry I'll be going a little bit deep, but this lecture is just for the basis of machine learning. But there's something I want to say. That is why, if you are actually familiar with building machine learning models, okay, there is something you will know. We have what we call the test and train data set. Okay, the test and train data set. Now, what is the train data set? The trained data set is like, for example, let's say we have a data, okay, and the data is 100%, okay. Now, this data is being divided most times in a ratio of 80% by 20% or 70% by 30%. Okay. Now, the ratio in which the data set is being divided should be based on the size of the data set. Now, this data set is being divided using this ratio. It is being divided into the train and the test data set. Now, what is the train and the test data set? The trained data set is actually used to train the machine learning model. Okay, the trained data set is the portion of the data set that is being used to train the machine learning model. Now, one thing you need to know is that the greater portion or the greater percentage of the data set is used to train the machine learning model. That means if you divide your data set into 80% or into 80 by 20% or into 70 by 30%, you assign the larger portion of the percentage, which is 70% or 80%, to train your data, right? And you assign the remaining 20% or 30% depending on the ratio you use to actually test your data. Now, the trained data set, okay, is actually used to train the data. This is the set of data that the machine learning model is trained on. This is the set of data that the machine learning model learns from. This is the set of data that the machine learning tries to understand seasonalities and patterns from. So this is where the training of the model, of the machine learning model, happens. Okay? Now let's talk about the test data set. Now, after, it's just like when you're in school, okay, you will actually be taught, maybe for a period of maybe a month or two, you'll be taught with different materials and all. Then after you're being taught for about a month, then you will be tested in form of exams, quiz, and the rest of them. Now you can actually see it the same way as training and testing your machine learning model. Now, after your machine learning model has been trained using the large portion of the data set, okay, then your machine learning model will now be tested using the smaller portion of the data set, which is the 30% or the 20%. Now, why is this machine learning model being tested? It's the same thing as why you are being tested as a student, to actually know if you have been able to understand the training materials and the resources that your tutor or your teacher has used to train you. Now, this is the same reason why the machine learning model is being tested, to know how the machine learning model has understood the data and how efficiently the machine learning model can actually make predictions using everything it has actually learned from the training data set. Okay? Now, this was me going a bit deeper, okay? But for this lecture, we are just basing this tutorial on the basics of machine learning. Now, like I mentioned, that machine learning is a subset of artificial intelligence, right? It's a subset of artificial intelligence that focuses, right, on building algorithms. On building algorithms, we have several types of machine learning algorithms, but that will be for another tutorial. Now, we said that machine learning is a subset of artificial intelligence that focuses on building algorithms that enables a computer, okay, to learn from and make predictions using data. Okay, now we can simply also say that machine learning is a subset of artificial intelligence, okay, that uses data, okay, to help a computer make predictions without the computer being explicitly programmed. So like I mentioned, a machine learning model is being trained on two types of data. We have the trained data and the test data, right? Now, after the machine learning model is being trained on the trained data, it is being tested on the test data. In a situation whereby the machine learning model did not perform accurately, when evaluated, right? There are ways you can actually evaluate your machine learning model. That will be a lecture for another day, where we have the ROC, we have the precision, we have the accuracy, and the rest of them. Okay, but that will be for another lecture. Now, when the machine learning model is being tested, and if the machine learning engineer feels like the machine learning model is not performing, okay, as he or she wants the machine learning model to perform, then the machine learning model will be retrained. Okay, the machine learning model will be retrained, okay, and tested again. Now, let's talk about types of machine learning. Types of machine learning. Now, we have 4 types of machine learning. Machine learning is categorized into 4 different types. The first category is we have the supervised machine learning. Okay. The second category is the unsupervised machine learning. Unsupervised machine learning. Okay. Then the third category is the semi-supervised machine learning. Semi-supervised machine learning. Then the fourth category is the reinforcement machine learning. Now, this is actually the 4 categories of machine learning. Okay, and some of these categories of machine learning have their subtypes. Okay, some of the categories of this machine learning have their subtypes. Okay, now we are going to be starting from supervised machine learning. Now, let's say you are writing an exam, and you are actually placed in a classroom, and you have about 3 invigilators supervising what you are doing. Okay, now let's say you are taught, maybe after being taught for a month, then you were given an exam, and you have 3 supervisors supervising what you are doing in the exam hall. Okay, because it is believed that, okay, we have taught you, okay, we have given you all you need, okay, to write this exam and pass this exam. So during your exam, you see the supervisors coming to supervise you. Now we can actually link that to supervised machine learning. Okay, because in supervised machine learning, the target is actually given to the model. Okay, there is what we call target. Sorry, there is what we call target or label. There is what we call target or label. Now, in the situation of supervised machine learning, a target or a label is already given to this model. Okay, now this model knows what it is trying to predict. This model knows what it is trying to predict. The target is given to it. It knows what it is trying to predict. Now, this is what we call supervised machine learning. Now, in this supervised machine learning, the model is trained on a labeled data set. The model is trained on a labeled data set. So what the machine learning model is trying to predict has already been known. It has already been targeted. It has already been labeled. Okay, so the machine learning model is trained on a labeled data set. Okay, now this supervised machine learning model is divided into 2. Okay, number 1, we have the classification. Sorry, let me clean this, please. So number 1, we have the classification supervised. So number 1, we have the classification supervised machine learning model. Okay, now another name for classification supervised machine learning model is binary. It's binary supervised machine learning model. Now, like the name implies, binary. Now, when we are talking about binary, we mean 2. Okay, 2. Binary means 2. Now, in the case of this supervised machine learning model, we always have 2 classes. there are always two classes, okay, which is the true or false. Okay, there are always two binary classes, yes or no. Now, in this situation, the machine learning model is just trying to know, is this event going to occur, yes or no? Okay, is this person going to default in paying his or her loan, yes or no? Okay, is this customer going to default in paying their loan, yes or no? Now, this is what binary classification task is all about. It involves two binary classes, the positive and the negative binary class. Okay? Another example of classification supervised machine learning model could be your spam email. Is an email a spam or not? Yes, it is a spam. Yes, no, it is not a spam email. Right? So this is what binary or classification supervised machine learning is all about. It involves two classes, which is always the positive class and the negative class. Now, it is actually the duty of the machine learning model to actually predict, okay, on a labeled data set, if a customer is going to default in repaying their loan, or if a customer is not going to default in repaying their loan. Example 2, if an email is spam or if an email is not spam. Now, this is just what the binary classification model is all about. Now, the second type of supervised machine learning model is the regression supervised machine learning model. Now, what is regression supervised machine learning model? Now, regression is gotten from a Latin word called regressus. Regressus, right? Regression is gotten from a Latin word called regressus. Okay? Now, what does regressus mean? Now, regressus means to walk or to step. Okay, regressus mean to walk or to step. Now, let's link this to regression machine learning model. Now, regression machine learning model is a type of supervised machine learning model that actually predicts continuous values. Yes, so regression supervised machine learning model is simply a type of machine learning model that actually predicts continuous values based on imputed features. Now, let me give you an example. Now, let's say we want to predict the house prices in Chicago in the next 5 years. Okay, let's say we want to predict, like we want to know what will the house prices in Chicago be in the next 5 years. Okay, now, as you can see, this is a continuous variable we are trying to predict. It's unlike the binary classification task that involves two variables or two classes, which is the yes or the no, or the positive and the negative. But in this situation of regression supervised machine learning model, we are trying to predict continuous variables. We are trying to predict continuous variables based on imputed features. Now, let's say we are trying to predict house prices in Chicago in the next 5 years. The imputed features could be how many bedrooms do the house have? It could be the size of the house. It could also be, is the house a new building or an old building? Now, these are what we call the imputed features. Now, the regression machine learning model predicts continuous values with using imputed features. It is unlike the binary classification model that predicts a yes or a no answer. Now, let's go over to unsupervised machine learning model. It is actually very safe to say that the unsupervised machine learning model is the direct opposite of the supervised machine learning model. Now, unlike the supervised machine learning model that is being trained on a labeled data, the unsupervised machine learning model is not trained on a labeled data. Now, the unsupervised machine learning model is trained on an unlabeled data. which means that there is no explicit output provided. Okay, there is no explicit output provided. Now, it is actually the responsibility of an unsupervised model to actually find patterns and seasonalities without any provided knowledge of what to look for. Now, when we are talking about the unsupervised machine learning model, it is actually divided into two types. Okay, number one, we have the clustering unsupervised machine learning model, and number two, we have the association unsupervised machine learning model. Now, what is clustering unsupervised machine learning model? Now, for example, let's say in a class, right? Let's say in a class of 10, okay, we have 5 students that are very smart, okay? 5 students that are very smart, that are very intelligent, okay? And let's call them the A students. Now, let's say we also have 3 students, okay, that are not as smart as these 5 students, but they are actually intelligent, but they are not as intelligent as the 5 other students, okay? Now, let's call them the let's call these 5 students the super smart students, and let's call these 3 students the semi-smart students. Now, we also have 2 students, okay, that are not intelligent at all. They are slow learners. Now, let's group them into slow learners. Okay, this is what clustering is all about. Now, we can simply say in this group of students, we have 3 clusters. Let me take that again. We can simply say in this group of 10 students, we have 3 different clusters. Cluster A is the super smart students, which is made up of 5 students. Cluster B is the semi-smart students, which is made up of 3 students. And cluster C, or cluster 3, is the slow learner students, which is actually made up of 2 different students. Now, this is what clustering is all about. Now, we can say clustering is a type of unsupervised machine learning model that groups similar data points. It is a type of unsupervised machine learning model that groups similar data points, just like the example we have seen here, right? And each group is called a cluster. Each group is called a cluster. Another example we can give is customer segmentation, where customers are being clustered or grouped based on their purchasing characteristics. Now, let's talk about association unsupervised machine learning model. Now, one thing you need to know is that this machine learning model is actually built on what we call the association rule. Okay? Now, let me give you an example. Have you ever walked into a mall, okay, to actually get groceries? Okay? Let's say you get into the section of the mall where you want to actually pick up your cream, okay? Where you want to actually pick up your cream. Then when you look by the side, you will actually see soap section, okay? When you look by the side, you will see soap section. When you look by the other side, you will see toothpaste section. When you look by the other side, you will see maybe toothbrush section, okay? Now, let me give you another example. Maybe you walk into a mall to get a pair of trousers, okay? Now, just at the right-hand side of the shelf where you see your trousers, when you just look above it, below it, or beside it, you will actually see a section with shoes, okay? When you look the other side, you will see a section with shirts. When you look the other side, you will see a section with maybe belts or watches. Now, this is what we call the association rule, okay? This is what we call the association rule, or association unsupervised machine learning. Now, the big question is, what is association unsupervised machine learning? Now, association machine learning is a type of unsupervised machine learning that aims to discover relationship or association between variables in a large data set. Let me take that again. Association machine learning is a type of unsupervised machine learning that aims to discover or uncover relationships or associations between variables in a large data set. Just like I gave you the example of a mall. Now, this type of machine learning is actually used to find rules. It is actually used to find association rule. For example, if a customer buys A, he would want B. If a customer buy bread, he will want butter. If a customer buy milk, he would want chocolate. If a customer buys a pair of trousers, he will want a pair of shirts. If a customer buy a pair of shoes, he would want a pair of socks. Now, this is what association rule does. Now, one of the most popular algorithms of association unsupervised machine learning model is the a priori algorithm. The a priori algorithm. It is spelled as A-P-R-I-O-P. It is spelled as A-P-R-I-O-R-I. The a priori algorithm is one of the most popular algorithms of the association unsupervised machine learning model. Now, let's go over to semi-supervised machine learning model. Please, if you have any questions, leave your questions in the comment section. Now, what is semi-supervised machine learning model? Now, this model is a combination of supervised and unsupervised machine learning model. Now, in this semi-supervised machine learning model, what happens is the model uses a portion of labeled data, okay, which is the supervised machine learning model, and it also uses a portion of unlabeled data, which is the unsupervised machine learning model, to improve the accuracy of its prediction. Let me take that again. I say that semi-supervised machine learning is the combination of supervised and unsupervised machine learning. In semi-supervised machine learning, this is what happens. Here we have labeled data, okay? Now, when we are talking about labeled data, which type of machine learning are we talking about? You got it right. We are talking about the supervised machine learning model, okay? Now, it also takes a portion of unlabeled. Now, when we are talking about unlabeled data, which type of machine learning model are we talking about? The unsupervised machine learning model, right? So it is safe to say that the semi-supervised machine learning model combines supervised machine learning and unsupervised machine learning to increase the accuracy of its prediction. Now, one thing you need to know is that this semi-supervised machine learning model is not as popular or is not as used as the supervised and unsupervised machine learning model. This type of machine learning model comes to play when the cost of labeling model is too expensive or time consuming. That is when there will be a combination of unlabeled there is when there will be a combination of labeled, which is the supervised machine learning, and unlabeled, which is the unsupervised machine learning models. Now, we can actually give an example of semi-supervised machine learning model. Let's say we are doing image classification with a few labeled images. This is when semi-supervised machine learning model can actually come to play. Now, let's go to reinforcement model. If you could remember when you are still in when you're still in high school, when you are actually given a task to do, if you actually perform well in that task, you are actually praised, or you're given a prize, maybe a pack of chocolates or a pack of sweets. But if you perform poorly in that text, you are scolded, right? You're scolded, or other students will be asked to laugh at you, or probably you're even flogged. Now, this is similar to reinforcement machine learning model. In this situation, the machine learning model learns on trial and error. Now, if the machine learning model predicts accurately, it is being praised. If it predicts inaccurately, it is being punished. Now, in reinforcement machine learning model, the model is allowed to interact with, and based on its interaction with the environment, it will be given what is called feedback. Now, in this situation, the algorithm actually takes actions to maximize cumulative results over time. Okay? It takes actions to maximize cumulative results over time. For example, we have our robot training. Okay, I'm playing games like chess. Now, this is what reinforcement machine learning is all about. Now, in this lecture, we have successfully explained what machine learning is. We also looked at the types of machine learning we have, and where we talked about the supervised machine learning, the unsupervised machine learning, the semi-supervised machine learning, and the reinforcement machine learning. Now, we also look at some types of machine learning under some of the categories of this machine learning. So we have come to the end of this tutorial. If you actually have any questions, please leave it in the comment section. In our next tutorial on machine learning, we are going to be looking at machine learning algorithms. And don't forget to like, subscribe, and share.